Hi, and welcome to this video on unions. Okay, so we're going to learn about unions in this video and what they are and what that means for our solutions. Okay, so when we talk about unions, unions contain the word or. Okay, so big deal, or is the word. So or is different from and because it doesn't mean and. Obviously, it means something or something else, one or the other. So for unions, if at least one inequality is satisfied, then that means that the whole thing is satisfied. The whole entire inequality is true. Okay? So when dealing with compound inequalities, you're dealing with two inequalities at a time. So that means that you have this inequality or this inequality. So what you're doing with a union is you're combining the possible solutions. Okay? So let's solve each one separately. So in example 2, I'm going to solve the first inequality. And notice that these are already separated. You won't ever see these combined into one. So I'm going to subtract 7 from each side. Okay, so those cancel. And so I'm left with negative 2m is less than or equal to, it looks like 6. Now I'm going to divide by negative 2 on each side. But remember that when I divide by a negative, that reverses my inequality symbol. So I'm going to be left with m is greater than or equal to negative 3. Okay, if you don't quite understand that, go back and look at the other videos on solving one variable inequalities, single inequalities. Okay, now I'm going to solve the next one. So since I don't have enough room, I'm going to come over here. So 5m plus 12 is greater than 37. And so what I have here is I'm going to subtract 12 from each side. And so I end up with 5m is greater than, looks like 25. And I'm dividing by dividing by 5, not m, because that would cancel my m. And so I'm left with m is greater than 5. So notice that the inequality symbol does not flip because I'm dividing by a positive number and not a negative number. So the only time you reverse the inequality is when you're dividing by a negative number or when you rearrange the order of the variable and the comparison number. Okay? So now let's graph each of these. So the first inequality is m is greater than or equal to negative 3. So here's negative 3. Negative 2 came before it, and negative 4 comes after it on the left side. So my solution is included on negative 3, so that's a closed circle, and it's greater than, so numbers greater than point to the right. Now let's graph the next one. This one is at 5. So 5, 6, 4 came before that. And this one does not include 5. So the second solution, 5, the comparison number is not included, but it also points to the right because it's greater than. And numbers get bigger to the right. Okay, so what I'm going to do is instead of graphing these separately, I'm now going to show you how to graph them onto one, just like we did with the intersections, except we're not looking for where there two are overlapping. Okay, so we're going to look at our solutions slightly differently. So let's look at the smallest number. Of these two solutions, when you want to graph them on one, you don't have to do this every time. You're going to start at the smallest number, and in this case, it's negative 3. So negative 3, negative 4, negative 5. Oops, that's totally wrong. Excuse me. Negative 3. What comes before negative 2? Negative 3 is negative 2. Negative 1, so we're counting backwards. And then 0, 1, and then 2, 3, 4, 5. And I'm going to go with 6 because I know that my solutions are bigger than 5. So, and then I probably want to come on this side and do a negative 2. So nope, not a negative 2, negative 4, excuse me. We count when we go bigger this way. Okay, so we have from 0 to negative 4 over here, and then over here I have from 0 to 6. Okay, so what I'm going to do is I'm going to graph the first inequality in blue, and so it's m is greater than negative 3. So negative 3 is here, and negative 3 is included in my solution just like it was before, and we know that the numbers get greater, so it points to the right. Okay, so then I'm going to come and graph 5 in a different color, and 5 is not included in the solutions for this inequality, but it also points to the right because it's greater than. Okay, so for a union, we only look for where there's at least one solution, whereas with the intersection, remember that we would only be looking at this region because it contained both solutions. Okay, so for a union, my inequality is true here because at least one inequality has solutions, and it's also true here because both inequalities have solutions. So it could be one inequality or both inequalities in order for the inequality to be true. Now where neither inequality has any solutions, well, that region will be false. There are no solutions there. Okay, so that's just a way of looking at it and being able to interpret the graph. Okay, so I'm going to pause this video and allow you guys some time to actually get some practice. Okay, And so for my solution for this one, my solution actually would be m is greater than or equal to -3 or m is greater than 5. Okay, so we use the word or. So make sure you don't use the word and, because that makes it wrong. And you would only be considering solutions over here when for a union, your solutions from -3 to 5 are also a part of your solution set. Okay, and 5 is also included because while 5 doesn't satisfy this inequality, it does satisfy the fact that m is greater than -3. Okay, so just keep those types of things in mind, that making sure that you follow the rules and that you're able to use those rules in order to read and interpret the solutions to your inequality. Okay, I hope this video has helped. I'm going to pause for a minute and then I'll go over the second two. So go ahead and do examples 1 and example 2 to get some practice on your own. Okay, so let's go over numbers 1 and number 2. So looking at number 1, it's a plus 1 is less than 4, or a minus 1 is greater than or equal to 3. Okay, so minus 1 on each side. Those will cancel. So a is less than 3. And over here I have plus 1, so a is greater than or equal to 4. So again, I don't need to graph the two separate graphs. I can go straight into graphing the compound inequality. So what my solution is a is less than 3 or a is greater than a is greater than or equal to 4. Okay, so let's do some graphing. So in this case, I have maybe 0, 1, 2, 3, 4, 5. Okay, so the first one I'm going to graph in red. A is less than 3. 3 is not included. And my solution set points to the left. And then for the next one, I can do that one maybe in blue. And that one is greater than or equal to 4. 4 is included. And my solution set points to the right. Okay, so notice this one is a little different from the previous one that we did. Up here, our inequality started in one direction, and then the other inequality joined it to continue the process. But in this case, our inequalities point in two different directions. Okay, well, what does that mean? Well, here, right, I have solutions that continue on in this direction forever, right? So any point before 3, my inequality is true. Any point between 3 and 4, not including 3, my inequality would be false. And then, of course, starting at 4 on, right, my inequality would be true, because at least one inequality is true in those places. So when it's less than 3, not including 3, so if it's like 2.999, then I have solutions there. That's a solution to my inequality. Once it hits 3, and maybe 3.5, 3.6, 3.99999, I have no solutions in that region. But then when it gets to 4, and from 4 on, so maybe 4 to 10 to 100 to 1,000 to 10,000, all of those are solutions that will satisfy my compound inequality with at least one inequality true at a time. Okay, so one thing I should do is I should also check my solutions to make sure they satisfy. So what I want to do is I'm going to pull solutions from the check region from where it's true. And so I want to check in both regions, especially if it's split like this, just to make sure that both regions are graphed correctly. So I'm going to try 2, because if my inequality is less than 3, if a is less than 3, then a of 2 would actually work in my inequality. So I'm going to say 2 plus 1 is less than 4. So I need to try it in the inequality that it satisfies, which is this one. So that would be 3 is less than 4. And of course, that is true. So my inequality checks out. And then I'm going to pick a solution in this region. Well, I should probably pick 2. I should probably pick 4, because 4 is included, just to make sure that I circle that right. So 4 minus 1 is greater than or equal to 3. And that is 3 is greater than or equal to 3. Well, that's true, because greater than or equal to means that it could be greater than or equal to, and 3 is obviously equal to 3. So that checks out. And then I'll test one more. Let's try 5. 5 minus 1 is greater than or equal to 3. That leaves me with 4 is greater than or equal to 3. And that's true, because 4 is greater than 3. So my solutions check out. So that's how I do checks for my inequalities. Okay, let's try number 2. In this case, x is less than or equal to 9. I don't have to graph that. So I do need to solve the second inequality, though. I'm sorry, I do have to graph that, but I don't need to do any solving. It's already solved for me. But I do need to solve the second inequality, so let's do that. Minus 2 on each side. That's 4x is less than 8. Divide by 4, divide by 4. X is less than 2. Okay, so what I have is x is less than or equal to 9, or x is less than 2. So let's graph that all in one. So I have 2, 3, 4, 5, 6, 7, probably need some more room, 8, 9, maybe 10. Okay, so there is my solution set, or at least my graph. So let's graph x is less than or equal to 9. 9 is here, 9 is included in my solutions, and it's less than or equal to, so it points left in this direction and goes on forever. And then now let's graph the second inequality, x is less than 2. Well, 2 is here, it's open circle, and it points left. It continues on to the left in that direction. But 2 is now included in my solution because of x is less than or equal to 9. So what I want to do is I want to pick 2 points to test. So if I needed some more points going this way, maybe I could pick 1 and maybe even 0. Okay, so I'm going to circle the points that I'm going to pick to check. Well, in the first region, my inequality is true, right? So this inequality is true here. It's false here. I shouldn't have any solutions in here. If I put 10 in, it should not work for either inequality. And if I did, 10 is not less than 9. And then if I put 10 in here, that would be 40 plus 2. That would be 42 is less than 10, and that's not true. So no solutions over there will work. But the solutions here should work. So let's look at those. Okay, well, when I check, let's try 5. I'm going to try 5. Well, 5 is not going to work in this inequality because this inequality is less than 2, right? So if I put 5 in there, it's not going to work. But 5 does satisfy x is less than 9. So 5 is less than or equal to 9. Well, of course, that's true. Okay, now let's pick one from this region, and it should satisfy this inequality. So since we've already checked it in this one, we know that this one is already satisfied because our solutions go on forever. But if I plug 1 into here, then that will tell me if it satisfies the second inequality. So 2 plus 4 times 1 is less than 10. So that is 2 plus 4 is less than 10. And so that 6 is less than, 10. And that is true. 6 is less than 10. Okay, so I hope this video has been pretty helpful. If you'd like to practice more, you can do the extra practice sheets that I gave you for homework, or you can look in any textbook and where you can find the solutions to the inequalities, and you can solve them and check your answers. So I'm going to do a video following this one on the different types of solutions that you could get, just so that you'll understand those things when you run across them and that you don't panic. Okay, I hope this video has been helpful, and I'll see you in the next one.